Hi everyone, welcome back to physics. We are going to try to make a couple of these lessons because we wanted to focus on the format, especially if you're planning on going into university stream grade 12 physics class. It will be important for you to be able to follow the format, and so hopefully this will be helpful. So just a friendly reminder before we start. Your notes, it's either from the package, if you're in from my class, Ms. Chan's class, you already have the package and it is the same lesson 2 that we were using. But if you don't have it with you, I understand some of you left them at school, and I understand Mrs. Boucher's class, you guys haven't started Unit 2 yet, which is okay. Make sure that you go to your Google Classroom, and we would have already posted the lesson for you so that you can still have that and follow along. So I'm asking you that please have your note ready and follow along. And if you don't have a printer, it's fine. Have some paper with you so that you can work through the problems with us. And especially doing the calculation part is easy when you watch us doing it. I want you to get used to writing down it with a proper format. Draw your diagram properly. Use the proper arrows that we always ask you to, and be mindful of it when you're doing your problem set later on to try your best to follow the format. And yeah, so if you need to pause the video and work along with the calculations, you're totally welcome to do that. I think that's kind of the benefits of the online learning, is that you can actually learn at your own pace. So hopefully you find that helpful. So I just wanted to recall what you've learned so far from lesson 1. Very important concept that it will keep on going is this thing called the free body diagram. I'm just going to write the short form. These are important diagram for Unit 2. This unit is called Dynamic, the study of forces. And the free body diagram actually is a diagram that keep track of all the forces that are acting on a certain body. And these forces will actually be able to help us explain how come a certain thing is traveling at a constant velocity, but then how come something else is accelerating. And so basically the rules are simple. Number 1, you draw a box. And then number 2, you actually put all the forces that could possibly be acting on the object, radiating from the center of the box. So some of the forces that you guys should have covered would be force of gravity. It's always going to be pointing downwards on the object. Force of tension is whenever there is a rope or a cable, it will always be along the string. And if an object is sitting on a surface, it will have this thing called the force of normal, and the direction is always perpendicular to the surface. You could possibly have force of friction whenever something is moving along a ground or something like that, and it's always going to be opposing the motion. That's the direction. And of course, when you're pushing or pulling, we call that the applied force. And then finally, if the object is traveling in the air, like if it's like a projectile motion, is a football being kicked, we also have something that's called F air. And don't forget, these are the forces that will go on the free body diagram. We're going to quickly just go through a lesson. It's more a skills based. Like a concept is really, really easy. It's more like that we need you to get used to knowing the format. So we're studying net forces. So basically, if I have an object, and if I tell you that if I have, say, 2 newtons, forces are measured in newtons. Okay, if I have 2 newtons going to the right, and I tell you that there are 4 newtons going to the left, and I'm asking you, hey, what's the overall forces that are acting on it? I think without doing any math, any calculation or written thing, you could easily tell me the overall net force is 2 newtons to the left. Okay, that's basically what we're doing. And don't forget that we're going to highlight this. Net force or forces is a vector quantities. And the significance of having something that is a vector is, number 1, it will have a direction. So it does matter if it's pointing top or bottom, left or right. And the number 2 is, if there's a change in direction, you can't just add the number, right? If direction is changing, you need to actually analyzing it like a 2-dimensional vector problem. And we're going to go through that together. And that's why in here it's telling you that if there are more than one direction, you're going to have to kind of break it down into the x and y. Yeah, we're going into components again. And or joining the component is using the Pythagorean theorem and stuff like that. Okay. simple rules that we want you to follow. We want you to draw a free body diagram all the time. Every single time when there's more than one forces acting on an object, we do require you to draw the free body diagram. Okay, we also do want you to indicate a direction. It might feel really not necessary right now, but as the question progresses to a higher complexity, it is important to follow this format because it will make it a lot easier for you when you're working on it. And then we want you to add all the forces in each of the directions by drawing the arrows. So let's study example number 1. They already did the first step for you, which is drawing the free body diagram for you. So the second step is they want you to kind of indicate kind of the direction that it's kind of more dominant, as in the overall net force. So 10 is to the left, 15 is to the right. So what we do is, I know this is simple math, we know it's 5 to the right, but the format that I need you to do is you're going to actually just use I like to use the wiggly line. You can use the straight line just to kind of indicate where the overall forces are going to be pointing. And then the next thing that we need you to do is you're going to actually write out X and Y axes. But as I said, in this question, we don't have anything along the Y, so you don't have to worry about that at all. You can just write the X component. And we're trying to study the net force, so we write F net. It's a vector quantity, so I have an arrow above the letter F, and I also would write down the little x just to represent that this is along the x direction. So we already have this red arrow indicating that the right is the quote-unquote positive direction. And what I need you to write down is you're going to write down the right side minus the left side, and the answer is 5 newtons. And you always have to write the direction down because they didn't indicate on the question. You can say right, and that's what I would put. Question 2, this time is different. All the forces are now going in the y direction, so we only need to analyze the y part. So the first thing to do is indicate the directions of the overall forces. 14 going up, 6 going up, and 17 going down. So we can kind of see that the total forces will be going upwards. And so if I were to write out the overall forces, similarly to what we did just now, but instead of writing the x, this is now going to be studying along the y direction. F net along the y, we're going to put an arrow above it because it's a vector. And because we said that the overall forces is going up, it's going to be up forces minus the down forces. So the up forces, the total of the up forces will be the 14 plus the 6 minus the 17 newtons that is going downwards. Overall is 3 newton. And because we knew that it is going up, we're going to write the direction. And one thing to notice, if you made a mistake and you put the arrow going downwards, and then you say, okay, because the arrow is going downwards, to find the net force is down minus up. If you do the math, you're going to end up with a negative number. But if you remember when we did vector before, really if you have 3 up, it is exactly the same thing as if we say 3 newtons to the down. So if your assumption was wrong and you end up with a negative answer, all you have to do is just change it to a positive and reverse the directions. Now this question is probably slightly more complicated. Not only that it has way more forces than before, it's also going along both of the directions. But the problem remains the same. You follow the same steps. So step 1, they drew the free body diagram for you already. Step number 2, analyze the x and the y and take a look at which direction it should be going. So if you take a look at the x forces, okay, the forces that are going horizontally, I have 18 to the right, 9 and 6 to the left. So first thing I'm going to do is I know the acceleration is going to the right along the x directions. I'm just going to do the x first, and then we're going to come back and study the y. Okay? So along the x, I repeat the format. I write F net along x. What does it equals to? Okay? When I have decided to put the directions going to the right, that is my positive direction. So I always take that side and I subtract the other side. But now you got to be careful. Okay, 18. The net force is 18 minus 9 minus 6. Some of you might tell me that this is 18 minus 9 plus 6. Common sense wise, tell me what answer this should be. without doing the physics. Like, just look at the picture. I have 18 to the right, 9 and 6 to the left. Is it okay if I say that that is 3 newtons? Because in together, if I take a look at the 9 and the 16 together, this is your 15, right? So 18 minus 15, that's 3. But some of you are going to write it like that because you forgot. We kind of need to group the same side together. And when I'm subtracting something that are together in the bracket, it really is minus minus. I don't care how you write it, but just be careful and mindful that you are taking care of that negatives. Okay, so 3 newtons to the right, and that's done for the along x side. And then along y now, I'm going to take a look at the numbers. 13, 7 to the top, 16 at the bottom. So overall wise, it should be going to the up directions. And since that is my positive, when I start doing the y directions, I'm going to write that the f net along y is going to be the up minus the down, because up is the positive. So it's up minus down. So up, I have 2 forces that are going upwards. I have to add them together, 13 plus 7. And then I have a force that's going down, so I'm going to subtract them. That is 16. So what we got there, it's now I'm going to have 4 newtons going upwards. All right, now what? X and Y, you know how to do that. Okay, so imagine if I have a box and I have somebody who's going this way at 3 Newton, and I have somebody who's going this way at 4 Newton, and I say, hey, if I have 2 forces that are pulling at 2 directions, common sense, which way is it going to be moving? Please do not just connect the dots. Some of you on the test is going to be like, oh, I got 2 vectors, I'm going to join them up like that. Okay? Does it make sense that if somebody's pushing to the right and somebody's pushing to up, that I would be going that direction? So please do not do that. Okay? Common sense wise, my overall direction should be going that way. And how do we achieve it? Basically, take a look at those two. You draw your triangle and you complete your map, your Pythagorean theorem, and your SOHCAHTOA, because this is going to be a right angle triangle. So starting point, it's like vectors again, okay? But this time, instead of a vector being a displacement or a vector being velocity that we did in Unit 1, it's actually a vector additions of doing net forces. So I got 3 newtons to the right. Notice the format is the same. I am careful that I have arrows there. I write my side, okay? And then I go 4 newtons going up. So from where I ended, I don't go back to the starting point, right? And I have 4 newtons going this way. So to complete the triangle, I always goes from starting point towards the ending point. And this time, instead of calling it delta dr or vr or whatever those symbols, we say f net. So the calculation of f net, because this is going to the right and going up, there's a 90-degree angle. So I'm allowed to use my Pythagorean theorem, and I'm allowed to use my SOHCAHTOA. So the angle I want to find, it's the same as before. Which angle am I finding? The bottom one or the top one? It's always streaming from the starting point. My angle theta that I need to solve for is the bottom angle. Okay, so keeping this quick. Right angle triangle, I'm going to use my Pythagorean theorem. Do your math. Okay, 4 squared plus 3 squared taking the root equals to 5 Newton. Okay, and then the angle that I need is angle theta. So 4 is my opposite, 3 is my adjacent. So TOA, tangent of theta, is opposite over adjacent. Punch it in your calculator. 4 divided by 3 equals second tangent. So the inverse of the tangent, it worked out to be 53 degrees. And you put your direction with your vector. Okay, so this is going, it didn't really indicate northeast, southwest. Since we're kind of using the right and the up, I'm going to say that this is going to be the right 53 degrees, the right 53 degrees going up. Okay, so finally, last question, question number 4. This is probably one of your most typical questions. Now that we've gone through, we know how to study the net force and stuff like that, we now give you objects. So they tell you a book is being pushed by 16 newtons to the right. The friction is acting to the left with a force of 6 newtons. And then they tell you that the force of gravity and the force of normal are both 10. They want you to calculate F net X and F net Y. Okay, first step, draw your free body diagram. You always draw your free body diagram. So you draw a box. And please don't just put the numbers straight in when they give you the name of the forces. So they told you that you got a box that's pushing to the right. We call that the FA, the applied force. Friction force is going to the left. It is FF. And then force of gravity is going downwards. And it's a symbol of F with a lowercase g. And then force of normal, it's always perpendicular to the surface. Okay, we're having an assumption that this is a level ground. And so we use F with a capital N with an arrow. Double check that you have these little things in mind, right? Like, did you put all your arrows above? Were there arrows at the end? Did your box with a dot in the middle? These are all the things you need to pay attention to. Okay. The next thing is we're going to add in the numbers. Okay. So I know that, like, if it's a really proper way, you should have done your given and all those stuff, but I'm just going to write it in. So FA, they told me this is 16 newtons and the friction is 6 and force of gravity and normal are both 10. I'm going to indicate kind of the overall net force. The net force should be pointing towards the right hand side. Now we're going to analyze. And same thing as just now, because it has forces going both directions, the X and the Y direction. You're going to have to analyze them separately. Okay, so F net along X. Along X, I got two forces, 16 to the right and 6 to the left. And because I say that it is going to the right, I'm going to go right minus left. So right hand side minus the left hand side. My overall forces is 10 newtons to the right, because the question said right and left. I know for sure I can write that. Okay, net force along Y. Now here is the part I know it's so obvious we know is 0. I want you to keep in mind, if I know that the net force is 0, there's actually a backwards thinking. Okay, I know the net force is 0. Do I go up minus down or down minus up? Or my even more important question is, does it matter that if I go up minus down or down minus up? Okay, later on, this is a very important concept, is that when you realize that there are a net force of 0, if I have a net force of 0, it really doesn't matter if I go up minus down or down minus up, because we will be analyzing questions in like a more in-depth way later on. I want you to keep in mind, if net force is 0, it doesn't matter if up minus down or down minus up. I don't know if you get what I'm saying, but we'll do more examples. Hopefully there's a chance that we can go through some examples that this will make sense. So it's 10 minus 10, it equals to 0. So overall net force, we found that it is 10 newtons to the right. That's my answer. Okay. So now the lesson is done. And hopefully that you find it helpful. We want you to visualize. We need you to see how we draw the free body diagram and how we analyze the force. And tomorrow's lesson are going to be based on the Newton's law. Okay, you'll be learning the Newton's 3 laws. But before that, I need you to do your homework and do some practice. So on your Google Classroom, we would have provided some questions. And don't forget, if you need more practice questions, you can always go to your textbook for more reference practices. And as always, if you really need to, right, get in touch with us. Okay, so have a good day, do your homework, and we'll continue our lesson on Google Classroom tomorrow. Okay.